Okay, in this topic we'll be looking at an example, a problem, and we're going to be working this problem and explain it much better. It is the angle between a tangent and a chord. Well, first of all, what's the tangent and what's the chord? This is the tangent, the point of tangency, right here at the point of contact. There's only one point of contact once you talk of a tangent. Okay, and if the point was at the center, then there would be a radius, okay, at 90 degrees, but there is no radius there. Now the chord is this piece here. That's the chord. That's a chord also. That's a chord also. Okay, they are chords because they're on one side by itself this way, so depending on how you look at it. Now this problem is stated by saying, given that ATB, A, which is on this side, T, B here, ATB is the tangent to a circle. Okay, so and CT, that's CT here, is the chord. If TDC, T here, DC, and I'm going to use this as red, 35.7 degrees. Okay, that's the angle. TDC equals 35.7 degrees, and angle TCE is equals to 47.8. okay, then we have labeled what you have been given in the problem. They are asking us to solve for TEC, this angle here, and for angle CTB, this angle here, and then angle ETA. So we will start with the first problem, and we're going to start solving it. So let me use a different sheet so I could do the work on the side so you can see it. So I want to start with the first one, solution. Okay, and I'm going to look for angle TEC. So let me keep this on the side here so you can see the working for the problem. All right, we're going to be working the problem beside it so you can see the image. So when we look at TEC, we're going to say that TEC, all right, is equals to TDC. TEC here, this way here, because that's what we're looking for. TEC is equal to TDC. These two angles are equal. Okay, so this is 35.7 degrees. Now how do I know that? So let me write down the explanation on the side. Angle TEC is equals to angle TDC, which is equals then to 35.7 degrees. Why? Because they are its angle in the same segment. Let's see how that and that is. This is the segment going all the way around. Their angles on the same segment. Okay, so therefore they must be equal. So this would be as if you were forget about this, you would have that. So these two angles are equal to each other. They're angles on the same segment, regardless if it's the major or the minor, but they're on the same segment, so therefore they must be equal. So you have solved the first part. Easy as that. Just recall the rules. Now for CTB now, so this is A, and now I want angle CTB. How do I go about solving that? Well, CTB, CTB, which is this angle here, okay, I want to solve that. So what I do is that I put that CTB is equals to TEC Okay, remember, C T B is equals to T E C. What do we call that? Which is equals to 47.8. Let's give it a reason why. The reason why is because they are angles or angle between a tangent and chord, okay, which is equal to the angle in the same segment. That's the rule that can be expanded. So both of them are the same thing. Okay, so you could angle between the tangent and the chord, or the angle in the same segment. So therefore, they will be equal. Now, or a next way to explain this is that it is the angle between the tangent and the chord which is equal to the alternating segment. Okay, so whichever way, it still works out the same depending which ones you want to work with. So you can work out with all of them, it doesn't make any difference, right? TEC, TEC. Sorry about that, this will have been 35.7. Just looking at this one here. So we have CTB, this angle is what we are looking for, is equal to TEC, this one. So this is the angle between the tangent and the chord, this angle here. Now this angle is also the angle in the same segment, because when you look at it, they are on the same segment. Okay, so that comes from this concept. So if you get the angles from this point, you can come this way, or you can go from this position to that point. So this is 35.7 degrees. Okay, and there are other ones that you can combine them. For example, you can say that CTB, this angle here, which is the angle between the tangent and the chord, is also equal to TDC. So this angle is equal to this angle is equal to this angle. Okay, angles between a tangent and a chord is still equal to the angle in the same segment. Okay, or angle in the alternating segment, it's the same thing. So that is for our solution for this one here. So we have 35.7 as the first one. Now for C, sorry, this was B. For C now, we are looking for ETA. ETA. Alright. Now ETA, it is now going from this position on the left hand side towards the right hand side. Here we were working with the left hand side towards right. Now we're going from right to left. The concept is the same. The only thing is that you're taking it from a different position, the numbers. Okay, so you have ETA, which is this angle, is equal to angle TCE, this angle here. So forget about this line here and this line in between, just look at it as a triangle inside of a circle. Okay, so therefore this is equals then to 47.8 degrees, and that is the reason why angle between tangent and chord, or it is also equal to the angle in alternating or alt segment. ALT just for abbreviation. Okay, in the same segment. So here it's just in the same segment, so we get that value. So here we have 47.8 degrees. So that's how we work what we call angle between a tangent and a chord. So if you just look at it, when you get pictures like these diagrams, forget about this middle line, forget about this if you're working with just that diagram. So you can work with that. If they put something like this, then look at them by forgetting about this middle line and worry about two angles in the same segment. All right, so that's how you can work with this one here. This brings us to the rule as to say that the theorem here said the angle between a tangent to a chord at the point of tangency, at the point of contact or point of tangency is equal to the angle in the same alternating segment. And by definition of alternating means you skip one and go to the next one. Okay, alternating segment of the circle. That's what the theorem states. Okay, so they can give you just a triangle like this and they ask you to work it out. Remember, this angle will equal to this, so you're the alternating one, the one that jumps. This one will equal to this. Okay, you put it this way, just imagine as if you don't have this middle line, you work with the circle theorems, angles in the same segment, and then you go alternating angles. Okay, so you will look at the problem from different perspectives. In other words, there's no one way to solve the problem, but the concepts are numerous. You will decide which one is much more easily reachable by you, much understood, and you can apply that.